and welcome to this BAKERpedia seminar today, all about objective bread measurement. I'm Dr. Jane Bach, and I'm going to be hosting the seminar today. Today's seminar is brought to you by KPM Analytics. KPM Analytics is the global leader in scientific instrumentation, focused primarily on analyzing critical quality parameters for food producers. They provide a comprehensive range of products and services to uniquely solve customer problems at every stage of production. Today, representing KPM, we have Arnaud Dubat. Arnaud is the Director of Business Development for Chopin Technologies in France, part of KPM Analytics. Arnaud holds a Master in Science and Technology for the agri-food industry and a Master in International Marketing and Strategy. His original background is in biochemistry, and he also holds a milling degree from the French Milling School. He started working for Chopin Technologies in 1989, and his various occupations within the company have put him in constant contact with flour producers or users worldwide. Arnaud is also a standardization expert for a range of standardization organizations, and he's active within BAKERview, a corporate member representative for ICC, and is also actively involved in AACC standardization working groups. So now I'm going to turn it over to Arnaud with that introduction, and he's going to share with you his presentation on objective bread measurement. Arnaud?
And yes, here we are to speak a little bit about bread. Thank you for all of you connecting us, and eventually for those of you that will look the recording afterwards. I have a quite dense presentation, not a lot of slides, but I want to describe a little bit what is happening, and particularly these last months where KPM particularly have been extremely active working with bakers. So I want to share a little bit what I've learned recently and how we are currently helping bakers to improve their flour specification by looking at the objective measurement of the dough character of the bread characteristics. Sorry. So here we go. I will start first with some facts, because we believe and we can see every day that we are in a very rapidly changing world. There are some facts that we need to take into consideration to understand what is going on right now. The first fact, and that was very clear to us when we are visiting customers, bakers, we always have this discussion. Okay, you have production issues, your product are not fitting the specification, the requirement of your customers, but do you have a flour specification, certificate of acceptance? And most of the time, the answer is yes. And so the question is, you have specification, but does it happen that flours are within specification, but still you are experiencing issues? And this is what we have as an answer. As you can see here, 96% of the people we have been asking this question have been telling us that yes, despite specification, flour specification, they still are not happy with the way the flour, the dough is behaving, or with the final product characteristics. And that can cost them a lot of money. Very interestingly, we had some people who say, no, if you are within the specs, it's always working. And if we look at that, it was always academic people, which means that they are not online. I'm not telling that they don't know. Of course, they know a lot of things. But there is a difference with the theory, which what we are learn at school and what one can see every day. So that's the first thing. There is something wrong with the way we are looking at flour quality and how it can ensure or make us sure that the final product will have the good shape, size, texture, whatever. The second fact, and of course we are all aware about that, everything is all the prices are rising. We can see here we have the flour price, so we have been reaching one of the maximum in the recent months. Also, we have the electricity prices which are on the rise. Take some example on some raw material like sugar and cocoa. All the pressure on the bakers, and when I say bakers, it goes from bread to cookie, pasta, whatever type of product. But let's say the final producer, they have a huge pressure on their cost, which means we need to have a way or to find a way to be more efficient when we are producing the goods, because this is maybe going to last for a while. So that's the second fact. The third one I want to draw to your attention is that every day we are visiting bakeries, we can see a lot of rejected product. Most of the time, this rejection is made by people looking at the product and putting it apart. There are some ways of reusing part of these waste, but it's really limited. And when you see at the numbers, it's really impressive. When you say that here we are speaking about 13,000 tons of food. Here we have Panera Bread that gave $100 million of unsold bread. So not only it costs a lot, but also now where we see the shortage of some supplies, and we see the people are more concerned about food waste. Maybe 10-15 years ago it was not really something of a big concern, but now the consumer, wherever, we don't like to wasting. We don't like to waste even less food. So knowing that the food I am eating, maybe 10% of the other product were wasted during the production, this is something consumers are more and more concerned about that. It's not only the economical impact for the company, of course. This is also another fact which is important. We need to realize that most of the quality control tools, here I am speaking about the Alveo, the Farino, the Extenso, the folding number, all these tools, they were invented 17 to 100 years ago. That's the first thing. Second thing, they were designed for millers. And the aim was to help the miller deliver a consistent flour. Because before that, they had no way of knowing if the flour was good or not good. So they were trying things, extracting gluten by hand, for instance. But the aim was for the miller to be as sure as possible the flour is consistent. At this time, this was what a bakery, a big bakery, industrial bakery, was looking like. You can see that there were two things. First of all, the automatization of the plant was very limited. So there were a lot of manual operations. And the second thing is that we had expert bakers here. So they knew that if something was going wrong with the flour, they can still twist it a little bit and make it work. So when we are saying consistency from the miller, it does not exactly mean adapted flour to a certain bakery. We had type, and we still have this type, baking flour, soft wheat product, this kind of thing. But one bakery doing bread can be very different from another bakery doing bread also. I insist on this one because I'm going to see the expert bakers we can see online right now. They are essential because they are correcting if the flour is not perfect. They are correcting because they have the knowledge. They know what to do. They know the line. They know the product. They can take a piece of dough and know exactly what to do. This is also one of the things I want to discuss with you, but in a few minutes. I want to come back into these quality control tools that we are using today. I'm not saying they are bad. I'm just saying that the traditional way of looking at flour quality is today finding its limits. And it can sometimes be extremely misleading. When you have this kind of things, and you can find this type of advices, or you can hear this type of advices many times everywhere. Here we are saying that if we want to make a nice white sandwich, we need to have flour protein, and we are normally happy if the flour protein range between 10 and 11.5. This is the theory. When you put this theory into action, this is what happens. Here, you have the slice area, which is basically the bread volume, and here you have the range, which is mentioned here, between 10 and 11.5. So for the same amount of protein, you can end up with this product or this product. So if your specifications are based on protein, there is absolutely no secret that you might have very different end products. And it is extremely frustrating. Why? Because between the flour that you receive and the final product, there is a lot of things happening. Or there are a lot of things happening. Okay, that's where we have the flour, we have the final product. Here it's a bread, can be something else, but here there is something happening here. So again, when you see this kind of thing, what trends to choose for a good pizza? This is again kind of thing of advices you can see from the internet. And they said, okay, you need a W value force from blah, blah, blah. First of all, a W value itself, just alone, doesn't mean anything. You can have the same W value with very different flour. So that's the first mistake of this indication. The second mistake of this indication is that these numbers, they do not take into account a lot of very important parameters. We are not going to the bakeries and telling them, oh, this is the flour you should use. Why? Because we don't know. We don't know what. We don't know what is the type of product they want to do. And if we know the type of product, we don't know what they really value. Is it the volume? It is the taste? It is the chewiness? It is the crispiness? That changes a lot. If you look about a pizza in Napoli, in Italy, and a pizza in Chicago, they are both pizza, totally different. I'm not saying there is one which is better than the other one. It's personal taste, but for sure, we are not going to need the same flour, and we are not going to assess the quality of the final product the same way. Because the consumers, they are looking for something very different. And this is what we have to deliver as a baker. So being able to really know what we want to do, what are the characteristics of the final product, is a key point. It's not the end point. It should be the starting point. And the way we are doing quality control and all of that is always the end point. We try to predict, oh, the bread should be like that. And we see it doesn't work very well. Why? Because also here we have a plant, and in this plant there are many variables. And one thing I know, two plants will never be equal, even if they do the same product. We've seen many times in the same plant, different lines, different production line, they are not exactly working the same way. And that's why sometimes the same flour, it goes well on line 1 and differently on line B. That's where the expert, the baker expert, are so great, because they can twist so you finally have the same type of product going out of both lines. The thing is that we should define the flour not predicting what it should be, but by taking into account the process specificities and the final consumer preferences. When I say that like this, it looks, a little bit maybe complicated. How can I do that? We will come to the solution, and you will see it's extremely simple to do that. Another fact also, and that's where I come back to the expertise of the bakers. We've seen the expertise of the baker is very important, because They are the ones that know what to do if the flour is not reacting as expected. Since the COVID-19, we have seen everywhere in the world that these experts are disappearing. They are disappearing because some of them, they decided to do something different. They want to have a different life, or some of them, they are just retiring. And as you can see here, we have the sector is struggling for skilled and experienced bakers. That's something we can find here in this review. And on the other one, they say clearly the veterans are retiring and we have not enough skilled machinists entering the market. And when I am discussing that with quality manager and even some of these expert bakers, they confirm that. And there is another thing, the people entering the companies, most of the time they don't stay enough to reach the level that they can really be experts and fine-tune the process. What does that mean? We need to find a way to keep this knowledge in the plant and not losing it. If we don't do anything, that will go away with the people having the expertise. And that will be a pity because now the processes are every day more complex and more automated. So we need to make sure this is working well. Another fact, discussing with millers, for millers is extremely frustrating. You know, they have specification, they have certificate of acceptance, and they strive to get their flour in this frame. And then they send the flour and they receive a phone call, it's not working, come here. So the main reason for that is that the specification we are using today, they are mostly based on commonly accepted criteria: protein, falling number, absorption, strengths. If we look well, a laboratory, a serial laboratory in everywhere in the world, most of the testing we are doing, they are based on protein content, protein quality. When you are making an alveograph bubble, you are looking at the protein tenacity, extensibility, these kind of things. But there is something we are not really measuring. It is starch properties. And starch is 70% of the flour produced and the flour bought by the bakers. And it is very surprising that 70% of the raw material goes without control. And that explains a lot of things that you can have. Many times people are telling me, Arnaud, I don't understand. I have the same alveo and sometimes it works and sometimes it doesn't work. Yeah, because the alveo is just giving you a certain vision of the quality. You need to have a wider vision of your quality because you are certainly missing the key point that makes that this flour provides you or help you producing a good product or not. And the reason is that the specification, they are not integrating the baker's process and recipe and specificities. The good news, because all of that is a little bit dark, but that's the life. That's the world we are living in, and nothing bad about that. The good news is that we do have solution, or solution exists. And these solutions, they are good for bakers, and they are also good for millers. The first thing I need to really stress on, when I hear that, and I hear that many times, no, I'm a baker, flour quality is my miller's problem. I really believe this is not the best approach for a baker really willing to improve their quality of performance, because flour is the key point of the final product characteristics. So it's not only a miller's problem, it's also a baker's problem. If it goes bad and you have a lot of rejection, it is your problem. The millers, they are doing a great job. They know how to fine-tune their flour and make them enter into the specification. But if the specification you give them are not good enough to prevent an issue or a problem, they are spending a lot of time and effort, but finally, we still have issues. And we have seen 96% of the people we have been asking told us, yes, I have specification, flour within specification, sometimes still give me problem. Of course, it's not the majority, but it still happens. So the idea is very simple, very, very simple. If we can learn from the process, and then we can identify what in a flour or in a dough makes that the final product is good or not, accepted or not, then the baker will be in a way better position to communicate to the baker, to the miller, this is what I need. These are the criteria which are important for me. I don't care about the protein, but take a look at this. Because I know, I have been doing the analysis and I know this criteria is impacting my process. If we do that, the millers, they will have a much better target to reach, and then they will use all the expertise they have, blending wheats, adding enzymes, additives, whatever, and they will send you a consistent, as they have been doing many, many years, but not only consistent, adapted. Adapted to what? Adapted to your process according to your indication as bakers. So finally, flour quality is also a baker's problem, even if it's the miller producing it. But the baker has the potential to give the miller the right indication for a better process. And everybody at the end, it's a win-win situation, really. So what is the proposal we are having now? It's very simple. Look and learn from the process instead of guessing. Oh, I have more protein. I should have a better volume. Oh, I have a bigger extensibility. My pizza should be wider. That's how we are reacting today. It is not working, but now we are going to look and learn from the process. The key point here is in the bakery. And I have been observing many times that the laboratory people and the production people, they don't speak to each other. It's very funny because laboratory people, they say, yes, we have issues, but I have been testing it and it's good. The flour is good, it's on the specification. And then the production guy that, yeah, but their specification, they are just useless. I am the one fixing all the problem. Okay, so that's situation we are seeing quite often. Now, what about these two people could communicate? That's the key point. If they can communicate, you can start learning from your own process, and you can link analytical data with the know-how and the expertise of the master baker. It's not about replacing the master bakers, because we still need someone to take action. We need to make the link between what we're observing at the lab and how it goes on the bakery. The same thing, you can link data with process observation. Is the dough sticky? Do we have a problem of extensibility in our baguette? I don't know. You can link the data with the final product issues because you are rejecting product. Why? Because it's too dark, because it doesn't have the good volume, because it's twisted. Why? So today we don't know. So it's, in fact, what we are experiencing today is a lot of subjectivity. And the key idea here is, first of all, communication between what's happening on the line and the laboratory. And the second one is to put numbers. Not only say, yeah, it was good, bad. No, put numbers. It's very easy. Numbers are our friends. So for doing that, we have a very simple pathway, let's say. So we are going to look at 3 places. When we are making a product, whatever the type of product, we need to mix flour and liquid and with water. Okay, so we are going to make a dough. We are going to make a big bunch of dough. We need to divide this dough. We need to put it in shape. That's where we are going to have other elements which are interesting. And at the end of it, we are going to bake, to freeze, to do something with the final product, because basically we are not eating dough. We are eating a final product. So these are the three steps, key steps, let's say. So first thing, we start by the end. That's what I told you. We are not going to look from the flour to final product. We are going to look from final product to the flour. And that's where it goes very interesting. If you look here, You can be baking, steaming, frying, freezing, whatever. At the end of it, you have a product that you are supposed to put on the shelf. And this product, you know, as bakers, what makes your product unique. You know it better than me. You know what makes that the consumer go to the supermarket to buy your product and not the competition one. It can be color, size, volume, whatever. It can be, you know it. So put names on that. And the other question is, when you are producing that, how much non-conform product are you doing? Do you know that? The characteristic of the dough just before the final transformation are critical. If you are baking a bread, the status of the dough after the proofing stage is critical. The question is, how do we control that today? How do we put numbers on that? How do we know? In fact, most of the time we don't put numbers. We just have the feeling, we touch, we know it was good, not good. We can do better on that. And the people doing better, they are really making progresses. So if we look at this here, how do we measure that? Most of the time, you have people at the end of the line and they are rejecting product. And you say, why? Because we have a poster and they should do. And you look what is in the bin and what's on the poster, it doesn't fit. I say, yeah, but you know, that depends on the people, on the same people. It depends on the day. That's the key point, because we need to know how many products we are rejecting and why. And the good news is that today, there are tools existing for doing that. If you can define objectively what is a good product and how many you are able to produce and how many you are rejecting, you can clearly have a clear idea of how your process is working. So we have a vision system, which are just taking pictures or videos of your product. I will show you some little things, and then you can use it for buns, bagel, tortilla, cookie, baguette, whatever, and you have objective measurement like that here. You have the size, you have the spot, you have the surface. You can ask them for many, many, many parameters. And the good thing is that if a product is rejected, you know why, because it was too big. Because you can reject a product because it was too big or too small. For you, it's rejected. But in terms of understanding why, it makes a big difference. So numbers are our friends. One day, a miller told me, and it really stayed in my mind, what I can measure, I can improve. And that's the key point. If you do not measure it, if you just guess or you know more or less, you cannot really improve. You cannot expect to improve something you are not mastering precisely. Today, the good thing is that we have very precise tool to help you on that. Now, if you go from the dough to the final product, or to the final product, you have this shaping of the dough. So sometimes very complicated, like here. So here, what are the bakers saying? I have issues with consistency, stiffness. Sometimes it's sticky, extensibility, elasticity. All these words are coming there because that's where we are going to move the dough. If we have proofing, the people are going to tell me about, yeah, sometimes the gas is escaping and I'm not retaining gas, or my volume is collapsing, my stability during proofing is not good. Okay, wonderful. Question, how do we measure that? What are the key points for you? If you are making a pizza, maybe the elasticity of the dough, you don't want the pizza to shrink. That may be a very important issue for you. Many times stickiness is an issue. How do we measure it? Because if we can measure it, we can improve it. And last but not least, from flour to the dough, there is the mixing stage, as you know better than me, and that's a critical point. We don't want to have something very sticky like that, because the dough processing properties, if they are doing well, perfect, you're going to make the final product, and then you're going to see that the shapes and everything are perfect. If it's not the case, you're going to have issues, of course, which are impacting your profit. You can still rework a little bit of the dough, but it's not really good to do that because you are impacting the quality of the next dough. So it's quite complicated to handle. And again, the question bakers should ask, how do we control that? And most of the time, the way we are controlling it is by looking, touching, is very, very subjective. So the proposal is to remove subjectivity as much as we can and replace it by numbers. If we have numbers, we can improve. How do we improve? Okay, so that's the solutions that we can say. So here you have a baking plant. whatever, the first thing, and I insist on that, it starts by the end. The first thing, we are going to objectively measure the quality of the final product and the process performance. We look what works well for a certain producer. How do we do that? We can have the product inspection. So that's, I was telling you about the vision system. So you have some example here. We can be working on color. We can be working on size. By instance, we have 3D things. We can look up. We can look down. We can also work on hyperspectral, which means that we can also detect foreign material. So that's tools. They are really giving you a vision of what's happening on your line. And it's not only by taking one piece of bread from time to time, they can analyze all your production all day long. So you have a real idea of what is happening. And if there is something wrong, you know what is wrong. Maybe it's wrong because the volume was too big all the time or too small all the time. If you refer that, or if you link that with the flour quality, that makes a big difference, knowing why the product was not conformed. And then you also have systems which are helping you rejecting the product when they are not conformed. So here you have an example on hamburger buns. Here you have the tortilla or the flat. You see sometimes you have one product going up, out, because it's not conform. And here for the bread, okay, so you see some bread droppings. Here, I hope it's not too small. Another one, another type of bread. Here you have dough sticks, and the same thing. Rapidly, oops, one bad. Let's go out. I like the next one, which is the cookie. You see the jumping cookie here. Oops, this one was not good. You have another thing. You can just put them out here, and you go. It goes very fast. And it is really looking at all your production. So you have a real image. Sometimes people are scared because maybe the rejection rate we are going to see are a little bit high, but it's better to know it's high so we can reduce it and take the measure to reduce it, than not measuring it really and still having it at the level it is. So that's the key point. Objectively measuring the final product characteristic, whatever it is. And if we can do that on all the production, it's even better. The good news is that today the technology allows us to do that. And it's something which is installed in many, many plants. Then the other thing is that you also have the possibility to understand your process by analyzing the dough on the process. It's not about analyzing the flour, because in your dough, eventually you have fat, you have sugar, you have enzymes, you have other things. So why not take a piece of dough and put it into an instrument? So here we have this example on the Mixolab. We have what we call the dough kit. And this dough kit allows us to have an image, a measurement, which is basically putting numbers on this expert filling. Instead of this filling, we are able now to say, okay, your filling corresponds to this consistency. And that's really helping transferring this knowledge into numbers. So now you have numbers at the end. You have numbers on your production. Why do you need more? You need to characterize the flour that helps you having the good numbers on your dough and the good numbers on your final product. So finally, you are going to look at the flour, which gives you a good dough and a good final product. And this is going to be transferred to your miller to say, Mr. Miller, my dough, my flour, which is working well, I'm happy with on my process, looks like this. So it's reverse engineering. So last but not least, my conclusion, and I will be happy to take some questions. The conclusion are, first of all, the bakery world is rapidly evolving for all the fact and reason we have seen previously. Of course, we are not all impacted the same way, but basically the global trend we can see worldwide as the one I have been mentioning in the beginning of my speech. So it is evolving. What we see, 96%, remember 96% of the persons say we do have COAs, but we still have issues and we still have flours not performing. Why? Because specifications, the way we have been looking at them for all the reasons, the good reasons I have been describing, they are finding their limits in this new world with plants which are running faster, more automated, with less possibility to human correction. So we are more attached to flower quality. But for the millers, it's very important to have the good target to reach, because they are, as I said, it's very frustrating to do their best and still have issues. So the new approach we have is really based, first of all, on objective measurement of the final product and the information on the final defect, what it is. It is the size, it is the volume, it is the height. Well, we need to know what happened. We can quantify, put numbers on the good, bad product that we are manufacturing. It's not about guessing anymore. It's about knowing. And because of that, we can also add the objective understanding of the dough behavior on your process. Do you know how the dough is evolving from the mixer to the end of the proofer with the many stages you have in your process? Most of the time you don't know. Maybe someone knows about touching it, but you are not able today, most of the time, to have a clear image of how the dough is changing after laminating or after sheeting, whatever. Now we have tools which are really giving us these very objective data. And because we have all of that, we are able to link the flour that helps us having a dough which is processing right and giving us the correct product with a good dimension, color, blah, blah, blah. All of that with data. That's very important. Okay, so we are daily working with Baker and implementing this strategy to more or less high level. And the good thing is that more and more we have millers joining us because they can see the benefit for them of having a better target. And really, the good thing is that it helps you work on parameter that really matters for your process, not something generally accepted because your process is specific. So of course we need to find a limit. We are not going to multiply this kind of event, but for a certain plant, it's very easy to describe the flower that better suits your needs. And I think I came to the end of my talk. Thank you very much for listening. And I will be happy to take some questions I have seen here. Okay, it's a good start. I have to be fair. That's a good start. Now, first of all, millers are very serious people. So when they have specification, they try to enter into specification. Okay, but it happens sometimes that for some reason, the flour you receive is not exactly matching the specification. Errors can happen. Something can happen. So if you're only basing yourself on the specification paper you receive, you're taking a risk. Maybe limited, but you're always taking a risk. One thing also very important I have seen, and I was mentioning that with the W value. Okay, I don't know how familiar you are with the LVO, but the W value is measuring a surface between the tenacity and the extensibility. So that's the surface here. If you say, if you're in your specification, you have a 220 W value, you can have the same one with a very low tenacity, very high extensibility flour, or with a very high tenacity, very low extensibility flour. It will be the same surface, so the same W. So you look at the numbers, you have the good W, but online it works totally different. So that's why trusting is good, controlling is always better. You should start by contacting KPM. That's a good idea. We can look at your specific situation because all the bakeries are not the same. As I said, the first thing, the important thing is to have a way of assessing the most objectively possible, the outcome of your process. Okay, so the amount of product rejected and the why it is rejected. So you can start by installing ways of measuring it yourself. I mean, you can start with something like, for instance, using a bread volumeter. It's already a good start. If you are making cookies, you can have a rack of 10 cookies and measuring the size. Do something, but put numbers. Put numbers. Then after, you will find that this is limited because you are not looking at the whole production. So the most of the whole production you can include in your numbers, the better it is. But as a start, try to find ways of putting numbers. We have had, every time we failed in making this connection between final product quality and flour quality, it's because the final product quality was not described precisely enough. So that's the key point. Yeah. It is. So that's the other step. So not doing anything, looking at the specs from the miller, and okay, the next step is I'm sending. That's good. That's a good point. The only limitation I see on that is that most of the time you receive a load of flour, and then you send one piece or one sample for testing. Sorry, and then you have to produce. Most of the time you cannot store the flour for many days. Sometimes it just goes very rapidly. So then you have problem eventually, and then you receive the analysis telling you, take care, the flour is not good. It's too late. So we have a very big customer in Mexico recently. They were doing that, and recently they decided to make their own test internally. So they have been investing in equipment because if you really want to control your quality, you need to be able to react very fast. And again, we are not speaking about slow pace bakeries. Now it's moving very fast. So it's nice to see that, yeah, it is confirming why the flour was not working, but you should prefer not to put this flour in production or to correct it or to know what to do. That's basically what we try to do.
The other thing that I would point out about using an outside laboratory, it is a start and it is helpful because you can start to put some numbers to what you're experiencing. But again, Arnaud made the point earlier in his presentation, only you know what optimal product quality is for the product that you're making, for the market that it's going into. If you send it to a lab like mine, I can make an independent assessment, but I can't tell you if this is your optimized product or not. So it is helpful to start there if you don't have instrumentation in-house to help you, but eventually you do want to move that in-house because only you know your product.
It's very true. It's funny because most of the time when there is a problem in the baking plant, the first thing we are blaming is the flour. That's directly. I have seen cases where the flour was not to blame, and yeah, it was the yeast because it was. Well, I'm not going to give you a secret, but basically there was a hot spot in the plant, and it was liquid yeast, and by going into this hot spot, we were a little bit cooking the yeast, so it was not active anymore. So then we had bread volumes, problems, etc. If you are doing a raised product like bread, you need to have two things. You need to have gas retention, which is related to the flour, but you need to have gas production, and you need to have a good balance between both of them. So my experience is that yeast tend to be a little bit more stable, or at least I hear less complaint from the bakers about the yeast, but it may be also because they don't test it most of the time. So maybe it's as big, but today we are more focusing on the flour. And I think I have seen some people using equipment for looking at assessing the yeast activity, and I think it's a very good idea to put that. Yeah. suppose it is a baker, and these are different silos. The question that's complicated. The question I would have is, are these silos filled with different millers? We recently made a study with a baking plant in Poland, and we have seen that they had 5 millers, I think, different, and one of them was slightly different. So if you attribute one silo per miller, it can be that the flour coming from the miller might be slightly different, which eventually you don't see with your specifications, because in that case, the difference were on the starch phase when we were looking at the mixolab. So it was impossible to see with an alveograph, for example, or a phainograph. So it can be this. So in that case, yeah, my advice would be to be able to test each silo and to know what is the quality of the flour in the silo. And if you can know what is good for you, that's even better.
Thank you.
It's also important to think about the location of your silos and the environmental conditions. Like Arnaud said, it's a very complex issue. And so it may not be the flour itself per se, but the environmental conditions, how long it's sitting in the silo. So the more that you can test that flour before you put it into production, the better handle you're going to have on what adjustments you may need to make.
Okay, standard rework person for dough and finished product. I can't answer this question. I can tell you, it's really funny. Let's say, okay, what I hear is that most of the people, first of all, it is something very secret. You know, I know it's like the flour extraction. When you are speaking with the miller, they always extract more than the other one, and when you are speaking with baker, they always have less rejection than the other ones. So it's hard to know. What I can tell you, most of the time, the people they admit to be between 2 and 5%, which is kind of I would say, okay, normal work. More than that, we might have a problem. For the rework, I have someone in Philippines telling me the maximum we are accepting is 2%. If it's more than 2%, we just put the dough away, because we know that more than 2% is affecting the new dough. So in fact, it's a vicious cycle. The more you re-inject dough and the more problem you have. So that's something you need to stop. For finished good, that's very interesting. I have seen a plant, they had a chart, and the chart was looking from 0 to 25%. Over the last weeks, they were more than 25%, because they put 25% because there is no space up. So it was, and I had the amount, I knew the amount of money they have been wasting. It was just impressive. So it can vary a lot. I had a tortilla manufacturer telling me that in winter, he was in Texas. He told me that in winter, they were around 8 to 10% problem, but when they go in summer, they could raise more than 20-25%. Okay, so the main thing is trying to reduce that. So if you want to reduce that, you need to understand what is happening. So first of all, you need to measure what is happening. Again, is it stickiness? Is it size of the product? So you need to be able to assess it. When you assess it, you need to you are able to link it with the flour properties and then make the link. Of course, it works if all the other conditions remain the same. If the flour is good, but the ambient condition goes from 15 degrees to 35 degrees, something's going to happen. But it is not the flour's fault. So it is also the baker's work to make sure that his production is consistent in terms of everything with material and working people, everything. So that's the first thing to do. You need to make sure that your process is under control. If your process is under control, then everything I told you is working. Of course, if depending on who's working on the thing, on the temperature, everything, it's not going to work. It will be too fuzzy. that's a wonderful start. Congratulations for that. So yeah, again, if you have an iPro, you have the information we need to. So now the next step would be to speak about, to discuss about the Mixolab, because that's really what we are using today. And on the Mixolab, we can offer you two things. Either we make the analysis of the dough. So in fact, of the dough, of the flour, sorry. You know which flour correspond to a well-performing process because you are measuring it. So the idea is just to take one sample of this flour and analyzing. And you do that 20 times, and then you will find what we call a profile, which is a kind of fingerprint of the flour, which are corresponding to the well-performing flour. And this is something you can communicate to the baker. So if you have an iPro, you are in the best situation, so we can definitely help you work with that. And the tool, the right tool, is the Mixolab. Why the Mixolab? Because the Mixolab is not only looking at protein, it's also looking at starch properties. So you have a very wide information on the flour properties. But we can discuss that later if you want.
And one of the other things that I really do like about the Mixolab is that you're looking at protein quality and starch quality within the context of a dough system. So a lot of other starch analysis tools, you have excess water to flour, and that's not the reality if you're working with dough. So it gives you starch properties within the context of the dough that you're working with.
Correct. I'm sorry. Every time I say it depends, but the reality, it depends. I would say if I need to put one point, I would say just after mixing. Knowing exactly how your dough gets out of the mixer is one of the key points, definitely. Then after proofing, before and after proofing can be interesting, but if I only have one shot, I would go after the mixer. For toppings, it depends. If the topping is one color, it's no problem. If you have a topping which is red and white and with different flour, with different colors, it can make it a little bit more tricky. And that's where having a vision system, the vision system basically is taking a picture, and then it can tell you, here you have 25% of blue and the rest is red. That's the benefit of the vision also.
So I just want to take the time to once again thank Arnaud for joining us today and giving us this presentation and spending time answering questions. And also thanking, of course, KPM Analytics for sponsoring the webinar. And with that, thank you everyone for joining us. We look forward to seeing you at our next webinar.